Hello, so today we are going to do this problem, which is part of Leetcode daily challenge of January. So the problem says find all anagrams in a string. Basically, we get two strings, S and P, and we want to return an array of all the start indices of P's anagrams in S, right? So basically, by anagram here, they mean just permutations, actually. Anagram in real life, it's permutation, but it needs to be a valid word. But here, what they mean really is just a permutation. So what we are looking for is, in S, we are looking for permutations of P, and what we want is the indices of the start of those permutations, right? And we want to return just the list of those indices in any order, right? So for example, here, P is ABC, so CBA is an anagram, starts at 0, so put 0. And then the other one that is available is BEC, that's a permutation of ABC and starts out at 6. So we have 6 here. So that's roughly the idea. In terms of the constraint, the length of each of the string is 10 to the power of 4. And we have only lowercase English letters, right? But from the length, if you do just a brute force scan, for S by P, you will get something to the lines of 10 to the power 8. So that won't pass. So we need something better. So let's see how we can do it. So let's think about this. So we want to get the permutations of P and find where they are in the string S. So one way to do it is to find all the permutations of P, do ABC, BAC, CBA, and just search for each one of them in S. But that's too big, right? That's going to be 2 to the power of the length here. So what we can do instead is just flip it a little bit. So instead of looking for the permutations of P in S, let's just go through all the substring of S, right? Of course, we only need to look at those of length P and just see if any of them is a permutation of P, right? And to check if two strings are permutations, it's actually very easy. You just need to check that the count of occurrences of every character in one of them is equal to the count in the other. So let's say ABC and BAC to find if they are permutations. Well, we can just use the count. So A occurs once, B once, C once, B occurs once, A occurs once, C occurs once. And if we compare these two counts, they are equal, right? Because B once, C once, A once, right? And that's enough to check the permutations, right? And so from that idea, what do we do here? So from that idea, we can use some sort of sliding window, right? Because we know, for example, here, we only need to check strings of length 3. There is no use in checking this one. It will never be equal, right? Because the length is different. And so we only need to check those of the same length. And so what we can do is just use sliding window exactly for that. And so we need sliding window and we need the counter for comparison. So first we can just have the count for P, right? It's just A once, B once, and C once. And then we can have our window that starts out with 3, the first substring of length 3, so it starts out here, okay? So first, C is 1, and we need to have a result for all the indices, right? The start of the occurrences of A, right? And so let's call that I starts out here, and we keep advancing. So if we keep advancing, then our I would be at, starts out at here, so I, but we can easily, let's say NP is the length of P. It's easy to find the starting position is just I minus the length of P. That's this position, the start, right? So it should be easy to check that. Now, let's do our counter for the window for our sliding window. C occurred once, B occurred once, A occurred once. So you can see the same occurrences for P count. So we already know this is valid condition, and so we need to add the starting position, which is I minus P, right? Plus that it's 3 minus the length, which is 3, so it's 0. You could try to calculate it here, but in that case, you will just need to do +1 here. So that works as well if you want to. So now we want to advance I. We found it. So we want to advance I, but we want to maintain the length, right? So we only need to remove this one, right? Because the window moved. And then we need to add this new one here. So we need to add C. We need to remove C, which means we need to decrement the window occurrence. So basically we need to do window of the S of I minus and P, right, is going to, we are going to decrement it by 1. Okay. And so we have 0, and then we need to add E. So to add E, we just, let's replace it. So E now occurs once. Okay, and so that's just by doing window of S of I is going to be +1. Okay. So now we move our window again. So we need to add the start position, which we said is 0. We move our window again. So our window moves here. Okay. Which means we now have this. So we need to remove this one and we need to add this one. And so to remove B, well, let's just remove it. And let's add B again because we just have it. So 1. Now this is still different than the P count because of this E, so we don't count it. So we move I again. Let's move I here. Let's move our window. Now our window is this. We need to remove this A. So we remove this A. And we need to add another A. So, and it's still not equal. And now we advance our I again. We advance our window. And now we have BAB. Now we need to remove this E, right? And add this B. So we remove this E and add to the B. So now we have 2 B's. Still not equal to the P count, so we continue. We move our I again here. We move our window. So now our window is here. We need to remove this B and add this A. So to remove B, we now have just 1 count. We add another A, so we have 2 now. And we advance our window again. So now we have here, our window changes to this, and we need to remove this A. So to remove A, we now have 1. And now we have a new C that we need to add. And now it matches, right? 1 C, 1 A, and 1 B. So what is the starting position? Well, this is after we are here. So it's 9 minus the length. Or actually, if we want to do with this position, then it's 8 minus the length, which is 3. And so that tells you it's +1. So it's 5 plus 1, it's 6. Okay, so we add 6, and this is the final solution. Okay, I hope that was clear. You need to be careful with these indices because it depends on where you put the check for window equal to count. If you put it at the end of your iteration or at the start of the next iteration, then you will need to do it differently depending on where you did the check, right? But it's either one of those. Yeah, so that's pretty much it. Now, in terms of time complexity, you saw here what we did. It was just traversing the string, so it was an oven operation, right? Because we did just 1 scan, and 1 oven scan, and is the length of S. In terms of space, we are using this P count and this window, and both are of length of P. So this is oven time and of, let's say, P, length of P. Let's call it NP space. Okay. Yeah, so that's pretty much it. Now let's code it up and make sure it passes test cases. So first we know we need the length of S and P, and we need a counter for P. This is just a counter to check against for the pattern. And then we have our window that we'll use in the sliding window. And then we need, of course, the result that we are going to return at the end. And we need an index to keep track of where we are. And that's the index that we will use here, as long as we haven't reached the end. And then each time, right, we reach for a window, we want to remove the starting position of that window because we are just sliding by 1 space, right? So to do that, we are going to say it's just at I minus the length of P because our window length is P, is the length of P, right? And so what we want to do is remove it because we are adding the new one at the end, so +1, right? So this basically, if you have A, B, C, D, E, A, something like this, And our window, let's say, was here, it's of length 3, right? So we move our window. So we need to remove this b here and add this e. And this b is the index is just I minus the length of p. Let's say p, the length is 3. So it's just I minus the length by 3, right? And then the new one is just this one that we added. And so we increment the number of its occurrence. And this one we are removing, we decrement the number of its occurrence. Now we just need to make sure for the starting position when we start out, right? There is no starting, we don't have a length of p yet, okay? So this in Python will go to the end of the string and set a value of -1 there. So we don't want that to happen. So we want to check here that this is bigger or equal to np. Because only then that we know we have a window of at least the size of the length of p, right? And now here at the end, we want to check if the window, the counter for the window is equal to the counter for the p, because if that's the case, that means they are a permutation of each other. They have the same number of occurrences of characters. If that's the case, then we want to add this to our result. But what do we want to add? We want to add the index of the start. So as we said, the start position is just I minus np plus 1, right? So this would be the position of, let's say we are here, this would be the position of I. And so to get, so let's say 0, 1, 2, 3. So 3 minus 3, that's 0. We want to do plus 1 to get here, okay? And so that should be it. Now, every time we want to, of course, increment I. So let's run this. And let's submit. And that passes, okay? Yeah, so that's pretty much it for this problem. Please like and subscribe and see you on the next one. Bye.